Welcome to Spring LIB.
In this exercise, we have a police car that's chasing a motorist. The police car has a speed VP equals 95 kilometers per hour, and the velocity is pointing to the west. And the motorist also has a velocity pointing to the west with a speed of Vm equals 80 kilometers per hour. And the police car and the motorist car are separated by a distance delta x equals 250 meters at the start of the chasing. In question A, we have to find what is the speed, what is the velocity of the motorist with respect to the police car. Well, in that case, the relative velocity Vr is just the velocity of the motorist minus the velocity of the reference frame. In this case, this is the velocity of the police car. So this is 80 minus 95. So this is minus 15 kilometers per hour. Okay, this means that the velocity is the speed is 15 kilometers per hour and the velocity is pointing to the east. In question B, we have to find the velocity of the motorist, of the police car with respect to the motorist. In that case, the relative velocity is the velocity of the police car minus the velocity of the reference frame, which is 95 minus 80, or 15 kilometers per hour, to the west. And in question C, we have to assume that they are originally 250 meters apart, and we have to find how much time does it take for the police to finally meet the motorist, okay, to get to the same place as the motorist. Well, all we have to do is to consider that they are moving with a speed of 15 kilometers per hour relative to each other, and then we can calculate the time as the distance between them, delta x, divided by the relative speed. The distance is 250 meters, and the speed, the relative speed, is 15 kilometers per hour, which, if we divide by 3.6, is 4.167 meters per second. Okay, so delta t is equal to 250 meters divided by 4.167 meters per second, which is equal to 60 seconds. Okay, so it takes 1 minute for the police car to overtake the motorist.